Hello, good morning, good afternoon, and good evening, all you people out there, to the second day of the A4Q Testing Summit 2026. I'm happy that you are here again and hopefully enjoyed the last day of the conference. And now we go in the second day and have a lot of great speeches today. And we will directly start with Alisa Hrustic. She is a 15-year experienced test manager and senior test automation engineer. And her topic will be AI as a test designer, transforming experience into automated testing. But before we go on stage, please don't forget, you can vote on the best speaker and best presentation also this day. Just follow this QR code. Hopefully it shows up in a few seconds. Yes, use this QR code so you can vote for the best presentation and best speaker. Yes, and all I have to say now, Alisa, the stage is yours. Enjoy.
Thank you. Thank you so much. So 10 years ago, if you wanted to test software to work as a QA engineer, you needed experience, intuition, and a lot of knowledge. The best QA engineers were always the ones who could predict how users would click, where system would fail, and where hidden edge cases lived. And this is, we will all agree, not an easy work to do. But today we are living in the AI age, in the world of AI, and it's amazing because AI can do something remarkable. It can learn from those behaviors directly from a data. For our application, every click, every failed request, and every unusual user flow hidden inside the application logs tells a story. Sometimes, as a test engineers, we can predict that story, but sometimes we cannot. But instead of relying only on predefined test cases, how we used to do in a traditional QA, now we can use AI to analyze real user behavior and learn how people actually interact with our systems and automatically design smarter, more realistic, and obviously more interesting test cases. The question today is no longer, can AI help QA? The real question is, what happens when AI becomes the test designer itself? What happens when years of testing experience, production issues, bugs, deployments, millions of user interactions are transformed into automated intelligence capable of generating, adapting, and evolving tests continuously? And that future is no longer experimental. It's already beginning to reshape software quality engineering and approaches we as test engineers have there. So welcome to the next evolution of testing, and let's build it together. But before we dive into this very interesting topic, I will just shortly introduce myself, even that was done at the beginning of the presentation. And also I will share the QR code for my LinkedIn profile if you would like to connect. So my name is Alisa, and currently I'm working as a test manager and senior test automation at System Verification. I hold master's degree from a faculty of electrical engineering in Sarajevo, and I have 15 plus years of experience in this area. My focus mostly was always test automation, developing test strategies for technical improvements, working to make teams working efficiently, and so on. But lately, AI has been very interesting to me, like for most of us, I would say. And currently, I'm working and investigating how AI can help, or how AI is going to reshape what we as a QA people do. But let's see what it looks like to work as a quality assurance engineer today. 6 years ago, during the COVID time, I hosted my very first webinar on the topic AI in software testing. And the topic itself was about how to implement self-healing mechanisms in automation tests. So we always know that if we have automation tests running, we will often have test automation failures. And we need to do triage to see what is the root cause for tests to fail. Sometimes tests fail, obviously, due to bugs, and then we are very happy because our automation tests are doing the work. But sometimes tests will fail because of some UI changes that are required, part of the requirements, user stories, and so on. So my topic back then was about self-healing mechanisms, and also today this is a very hot topic with, I would say, different opinions on it, but still very powerful and AI-driven. And back then, at the end of my presentation, I posted a question: will testers eventually go the way of the dinosaurs with AI applying to QA? And today, 6 years later, I would say that this question is still very, very much relevant. Being a test engineer has never been an easy job, but today role is, I would say, more challenging than ever. Not just because AI is reshaping a QA, but because it's reshaping a software development lifecycle completely. Development is accelerating, systems are becoming increasingly complex, and AI, as I mentioned, is fundamentally changing everything. So modern QA engineers, I would say, can be divided into two main groups, because term modern needs to be adapted, as a traditional way of working can no longer bring the results that we aim to have. So today, if you are working as a QA, you can be either a builder or explorer. What does that mean? Explorers are people who are continuously experimenting with the new technologies, new tools, AI-driven approaches to stay ahead in a rapidly evolving landscape. Builders, on the other hand, are creating their own solutions, developing internal frameworks, AI assistants, automation utilities, and smart workflows to improve daily work. And this is an example of that presented so-called solution that I had 6 years ago on self-healing mechanisms. Both are very interesting, but with the help of AI today, as a QA engineers, we can also bring a lot to the table in terms of solutions, not just automation tests. So old-fashioned tools, traditional approaches are no longer enough. And in the age of AI, and especially with the rise of vibe coding, test engineers are increasingly moving toward the builder mindset, using AI not just as a tool, but also as a collaborator in designing smarter and faster tests. My personal opinion, and I would say also experience, is that I would describe working as a test engineer as a racing against reality. And before we dive into AI-driven solutions and the new way of working in the AI age, let's first remind ourselves why software testing has always been such a challenging profession and where AI can truly help us. Why QA is a constant racing against reality? I've listed here a couple of most interesting and areas in which I've had experience, like QA joining late, user behavior is different from user stories, it's a time-consuming job, existing tests, even though we have a very good automation frameworks, do not find new bugs, but bugs still appear in a production. No matter how well we think our application is covered with the requirements, specifications, user stories, we can never fully simulate real user behaviors. because users interact with the system in very unexpected, creative, and sometimes completely irrational ways that are difficult to predict through the traditional testing approaches. And this is exactly where AI opens a new opportunity for software quality engineering. How many of us have seen this case in our jobs? And I believe that it's many of us, at least myself. I was on different projects working with a different kind of applications, believing that my so-called QA system works just perfectly, but then I experienced something like this in a production. And no matter how confident we are in our processes, in our test coverage, pre-release results, green tests that we execute after every deployment, there is somehow always users who are going to interact with our application in a completely different and unexpected way. Something that we could not predict because they are following different paths, performing unusual actions, and eventually causing application to crash. And this is not something that we want. We all know, especially if we have frequent releases, how painful it is to see something like this in a production. Even though quality of the product, it's not just the responsibility of the QA, it's responsibility of the whole team, we still know that we are the last one in the chain that give approval for something that it works good. So when we see something like this in a production, it's a very, very frustrating. And even though we believe we have a perfect process, we have a very good coverage, and we experience this, what else can we do? Because if we applied all our experience, our best practices, experience across the team, we establish good QA methodologies and still up in these situations. So what to do? I'm not sure if holding AI as our friend is a complete answer to this interesting and complex question. If this is the answer or it's a final solution, but it is at least something worth exploring, especially because traditional approaches still leave a lot of room for improvement. So what to do is to use AI to help us overcome our challenges. But next question is how we achieve that, how AI really can help us. And there are different opinions today on using AI in the QA systems and in a software development life cycle in general. I don't believe that AI is replacement, but it's a great addition so that we can build something more interestingly and to have a room for improving on and working on some other more human things that AI still cannot cover. So in case of our, let's say, problem, where we still don't know how to predict in a perfect way what users are going to do with our applications and how they will interact with our application, the answer to that is to build an AI-augmented QA system. So this is a short workflow, what that actually means. We will start with the application logs, because as mentioned at the beginning of the presentation, application logs is a place where everything happens. Our systems continuously generate large volume of application logs that capture real user interactions, system events, and edge cases. So what we can say is that these logs represent the most authentic source of information about how application behaves in a production. So if we have something like that at our disposal, let's use that. But before we can just use, logs and all data that we have from the application, we need to perform a couple of steps. And the next steps would be log normalization. Before we can use data from logs efficiently, it needs to be structured and normalized. And why is that the case? We often know that logs are very inconsistent, noisy, and very difficult to interpret. Very often, especially when I work as a mobile automation engineer, and I needed to find some application log crashes in the logs, it was always very difficult and very hard to go through logs to a lot of data just to find a couple of lines that will help me find the root cause of the issues that I've reported. So we need to normalize logs because of that. By standardizing formats and extracting meaningful signals from the logs, we turned unstructured data into a usable foundation for further usage. So after the normalized step logs, we will have, let's say, nice and structured data, and then we can proceed. And we will proceed to the AI part. And the next step to do is to prepare LLM prompt. So once the data is structured, we transform it into prompts for LLMs. At this stage, we translate normalized user behavior into format that AI can actually understand. And we capture context and intent behind user clicks and in general user behaviors. And then our final step and the main purpose of building such a solution is a test case creation. So based on the prompts, the LLM generates relevant and realistic test cases. And those test cases are no longer theoretical test cases that we derived from the user requirements, user stories, and specifications. They are derived from the actual user behavior and patterns based and observed in the system. And in this case, we can create more dynamic, adaptive, and production-aligned test coverage, which is something actually that we want. What I would just like to highlight is that this, what we can see here, it's a simplified overview of the solution. It's in reality, each step contains additional layers of validation, refinement, and feedback loops, but the core idea remains the same. So next, what we are going to do is to go through each and one step by step to see how we build and use this solution. So let's start with the data collection. And the precondition to use and apply this solution is to have good data. Data collection starts usually at the front end, where we capture real user interactions, such as browser events, API calls, and rendering errors. And this gives us direct visibility into how users experience the application in the browser and where the issues will appear first. What kind of flows they have, where do they click, and what clicks are actually generating some kind of errors, either on the UI or in the logs. Next step, what we can do is the API gateway logs. At the API gateway layer, we observe how traffic is routed across the system. Here, we collect information about requests, throughput, upstream issues and errors, and that help us understand not just behavior, but also system performance. And it directly tells us if there is a sign of some kind of degradation. And finally, we gather data from the backend services where the core business logic is executed. Here is the list of a couple of services that I use in my proof of concept. But we must say that every service contributes critical signals about the system behaviors, failures, and dependencies across the application. And then together, 3 layers combined with their data provide a complete end-to-end view of a system activity, from a user interaction on the front end to the back-end processing. But let's see how data collection step will result in a real practice, in a production. This is just one example, also from my example for my proof of concept. I'm showing this just to show how this data really looks like. It's a very highly unstructured, very noisy, and completely not suitable for LLM processing. So there we proceed with the next step, which is data processing. And this is the most crucial step for LLM to use. And in general, data, what we have with the data, the way the data is processed, normalized, the way that data is correlating inside, it's a crucial part, not just in a case of this solution, but for LLM in general. So first step, if you want to do with the AI, you need to have a good data. I have shown how the production logs, they look like. And honestly, to an LLM, this kind of input often appears as a noise. And without additional processing, it cannot be used. Because LLMs are very powerful at recognizing patterns, but they struggle when information is disconnected. So when logs are properly structured, the LLM can interpret user journeys and sequences that users are doing in the application. It's basically something similar to how human would read the timeline of events and understand intent, cause, and effects across multiple steps. However, once these signals are aligned and correlated, data transforms into a continuous flow. And this structured data context is exactly what an LLM needs in order to reason about system behavior, to identify root causes, and to generate realistic tests. Now, how to actually proceed with the data processing? This depends on your application setup, on the way how the logs are used in your applications, and whether there is already a tool used for this. There is a couple of tools, of course, that can be used for this purpose. But in a case you want to play around with your data, or you would like to try this approach with your application or your example, it is very easy to do the data processing by using a Python script. So you just need to prepare a script. You can use vibe coding approach, because the main goal is not to build a to build a tool that will work with logs, but to process the data and to make it suitable for an LLM. And then when we completed all that, we are navigating to this most interesting part, but also just to mention once again that this part will work just fine if the other steps are completed in a good way. So what we are doing here is a test case generation. The quality of the output is directly dependent on the quality of the prompt. Poorly defined prompts result in inconsistent, incomplete, or unusable test scenarios. AI is good, but is good if you are using it in a good way. So this becomes even more important if you are planning to integrate generated test cases into existing QA ecosystem, and that is often the case. So first thing to say is when building the prompts, where you are planning to use Gen AI to generate some kind of test cases, Test cases must follow a clear format and structure, including elements such as steps, expected results, precondition, test data, or eventually services that are used, backend services, or any other additional data that is important for you. Because without this consistency, they cannot be executed in the good way, they cannot be automated or tracked in a test management tool, because that is our actually final goal. In other words, prompt engineering, it's not just about getting an answer from an AI, it's about shaping the answer into usable QA asset that fits seamlessly into the software testing lifecycle. What I have presented here, it's just a basic prompt where I instructed LLM to generate test cases in a predefined structure, including both JSON and Gherkin formats based on the provided input, and provided input are normalized logs. Just to also highlight that this prompt is intended for just demonstration purpose. In practice, it can be more further redefined, extended, adapted on the specific requirements, needs, and level of the complexity in your system. And what we can here see is a result of AI test case generation, as mentioned, in the two most common formats that we as a QA engineers need. First one is a JSON, second one is a Gherkin. I prefer JSON because it's then a very good input for all other test case processing that I want. And what you can see here is basically a real user flow, dependencies on the services, test data, and similar. And when I initially generated these test cases, I had a lot of test cases, and I was very, very happy about the magic that AI did for me. But then I started to reviewing test cases, and I realized that the job is not completed there. AI did the good job, but it still needs a little bit of validation of the test cases that were generated. There, I introduced a final step, and the final step in this solution would be AI test case validation. Because generating test cases with AI is only part of the solution, and validating what AI generated for us is a critical step. And how we do that is by introducing a concept of LLM judge. And this concept, not just for this system, but in general, when building an AI-based system, is very common because it's a very powerful, and it helps us build better solution. So LLM Judge acts as an evaluation layer on the top of a generated output. And instead of simply accepting every AI-generated scenario, we use another reasoning process to analyze the quality, completeness, and uniqueness of generated test cases. So what an LLM receives is application logs, the same contextual data that were input for test case generation, and it accepts generated test cases in formats JSON, Gherkin, or whatever we like. And by comparing generated scenarios against real user behavior and existing flows, the model can reason about whether the test cases truly reflect realistic usage pattern, risk areas, and user behaviors. And what an LLM judge actually provides, what is the output? The output is usually a numeric score or rating showing how generated tests are good. And there is a rule that if the score is 75% or higher, we take that output, in this case test result, as a good, and we accept it. Additionally, and this is very useful in a case of test cases, is a qualitative and quantitative feedback in the form of explanation. especially for the tests that are not accepted because they have a low score or rating. For example, this test is a duplicate of an existing checkout flow, and so on. Additionally, LLM Judge can also be extended to do recommendation. Like this test case can be kept if it will be modified, additional data is needed, and so on. So after we perform the LLM Judge, we have a final list of our accepted test cases. And then what we do with that cases, it really depends on our ecosystem, our current way of working, and eventually what do we want to do with them. Sometimes we want to integrate them into our existing test management tool, but I would always prefer also automating them because that is the final goal, to have test automation for the tests that are derived from a user behavior. So this is our little solution that will help us build tests based on the user experience. And what we are going to achieve with this solution and with this presentation, what we need to understand is that AI is not replacement, it's an enabler. It will just empower us as QA engineers to test smarter and more efficiently. We will close the coverage gaps with this way because we are going to generate flows that we probably could never do just based on our understanding on the documentation. And maybe the most important one is the future role of QA engineers, where we are shifting from test cases creation to working as a QA engineers in AI-driven systems. So thank you very much. I hope that you enjoyed the presentation, that you have received some, at least, ideas how to play around with the AI. So I'm now ready for any comments, questions, notes, suggestions.
Yeah, Alisa, thank you very much for this insights, for these ideas you shared with us here. We have some questions here, so maybe we can go through them. The first one is, how often should we analyze logs and recreate the tests?
This is very interesting question, and it really depends on the context and the place where we put this solution. If you already have a solution in place with, I would say, existing test cases for a particular, I play around with the checkout flow application. So if you already have tests in place and you just want to extend your current test coverage, the first initial round of analyzing logs and creating tests is the most important one. And then you should also follow and get either from a product owners or other stakeholders information on the new users in some area, a couple of months, let's say, then newly developed features that you released and so on. And after combining all of that, I would say that it's okay to do twice a year, because we don't expect AI to find a lot of differences with the new users and then with the new features being developed, and then if you already have in place some kind of tests.
See, thank you. And the second question, can any other type of information can be used or explicitly logs like described in the presentation?
Basically, any type of logs. The logs that I've described are the ones that every application has, or at least it should have, together with some others' information. But front-end logs, back-end services logs, and then the gateway API layer are something that every application or solution has, so you can take that. But it's a plenty of options to play with the solution. You can introduce, for example, if you have a good user requirements, you can also introduce your existing test cases or any other metric that you have. So not precisely only the logs that I've showed. This was just a proof of concept and one idea, but then since the data is the most important part for an LLM, the better and the more different kind of data you have, you will probably have better solutions as well.
I see. Yeah. Thank you. And I think we have another question here. Can the test cases be input for API tests?
They can. They surely can. Example here in my case is for UI tests, because I use that kind of application for playing with it. What I would just suggest in a case of API tests is when it comes to analyzing the logs and normalizing the data. So the second step is when that part is finished, and when we navigate to the third step, which is prompting, is to just modify prompts a little bit, because the prompt that I've showed is what we want to see as a user flow. And then API tests can be different, depending on different services, probably on authorization stuff. So it can be used, but just the prompting part should definitely be different a little bit. And then in that case, front-end logs could be eventually ignored, and some other layer of data could be included.
I see. Yeah, thank you very much for clarifying this and for answering this, and for your presentation too. So if you like this presentation, you find here the QR code for the voting for the Best Speaker and Best Presentation Award. And Alisa, thank you very much that you were here on stage, and I hope you also enjoy the rest of the conference here, and have a good day. Thank you.
Thank you. Thank you so much.